In this video, we are going to see about a Python IEEE project which is entitled as Obesity Risk Prediction Using Machine Learning, which is an enhancement of IEEE base paper titled Deep Health Net Adolescent Obesity Prediction System based on a deep learning framework, which is an IEEE 2024 journal paper. Before seeing the execution of the project, let me brief about this project. So we all know that obesity is a major problem in all over the world to the human being. Because of this obesity, there are various kinds of problems occur to all the humans. It may cause diabetic, it is the major cause for the diabetic, it is the major cause for heart diseases, heart attack kinds of thing, and there are various kinds of lots of problems are occurring due to this obesity. This obesity is caused due to various reasons. If we are saying particularly about not having exercise, not doing physical activities, there is a change in lifestyle, food habits kinds of thing. There are various reasons available. So in this base paper, the authors have used the deep learning framework for predicting the adolescent obesity. So this paper uses the deep learning framework, and they are using the data set of the adolescents. So especially it is named as Would You Do It, WUDI. So here they have used 321 participants with aged 10 to 12 years, 133 males and females. So based on that, they have collected the data set, and they are having the physical examination of height, weight, BMI, and they're collecting the data of step count, sleep time, these kinds of details, and then based on that they are making the obesity prediction, and they have achieved the accuracy using this deep learning model. They have achieved the accuracy around 88%. But kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about what is our proposed system and what we are enhanced from the base paper. So we are going to predict the obesity prediction, but we are not going to use this data set. Instead, we are going to use a standard obesity data set, so that we are collecting the various features and large number of data. We are going to accurately predict the data obesity prediction. So first let me tell about the model that we are going to use. So the existing system, the base paper is using the deep learning framework, but we are going to use two different models, machine learning models, XGBoost classifier, the first one, second one is stacking classifier. So the accuracy that we have achieved is train score of 100% for the first model, XGBoost classifier, and achieved the train score of 100%, a test score of 98%. And the second model, stacking classifier, also achieved the accuracy train score of 100% and test score of 98%. The first thing that we have enhanced is we have used two different models, and also from the existing system, model achieved lower accuracy around 80% only, but we have improved the accuracy up to 98%. The first thing that we have modified, enhanced from the system is the model, and second one is the data set. Now let us see about the data set part. So here you can see the data set that we are going to train the system. So this data set contains around 2111 data set records. So here you can see there are various features available like gender, age, height, weight, family history with overweight, FAVC, FCVC, NCP, CAEC, smoke, CH2O, CC, FAV, FAF, TUE, CALC, MTrans, no bias dat. So now let me explain about this dataset feature. So FAVC means frequent intake of high calorie food. So that has been described here. FCVC means frequency of vegetable consumption. NCP means number of main meals per day, and CAEC means consumption of food between meals, and smoke is the smoking habit. and CH2O is the daily water intake, how many liters kinds of thing, and SCC means soda consumption, and FAF is physical activity frequency, TUE is time for exercise, CALC means caloric intake, and M-trans is transport medium, how they travel for going to one place like that, and no bias dat is the final obesity level. So here you can see there are 7 classes available, and like normal weight, overweight level, overweight, 2 kinds of thing. Let me explain those details. So this is the data set that we are going to use. So now coming to the document part. So here you can see the proposed title, obesity risk prediction using machine learning, and IEEE base paper title, adolescent obesity prediction system based on deep learning framework. So this is the IEEE base paper abstract. So coming to our proposed abstract, so here you can see that we are going to use machine learning model, which is XGBoost classifier and stacking classifier, which uses the Python as a coding language, Flask web framework, using the Frontend part, HTML, CSS and JavaScript. So that is being described in the proposed system parts. And coming to the model part, you can see about the model name and the accuracy that we have achieved is being described in this part. And coming to the dataset part, so the dataset contains 2111 dataset record with 17 attributes, whichever I mentioned you. So those attributes have been mentioned here. And by integrating these advanced machine learning techniques, so we are going to develop a user-friendly web interface so that the obesity risk prediction can be calculated using the machine learning model. So coming to the existing system, so we are taking the base paper as existing system. So in the base paper, they have used the deep learning framework, so that is being described here detailedly. And the dataset part contains 321 adolescent dataset record, which is about would you do it application from, so those details have been done in it. And then the accuracy part is 88%. So here, and additionally the existing system highlighted gender based variation, so how many boys and girls have been done, so that is being done in this deep learning framework. So the overall about the existing system is being described in this part. And coming to the disadvantage of the existing system, this is the first disadvantage is the accuracy part. They have achieved only lower accuracy, but we have improved the accuracy. And another thing is the data set contains only lesser data set records, but around 321 only. We are having larger data set records, covering the various features. In the dataset part, that is it contains the features, limited features only in the existing system, but we are using the complex dataset which larger dataset features in it. So another disadvantage is they are using the deep learning framework, so it requires a large amount of high quality data, but is not done in it. So another drawback of the deep learning framework is inherently complexity. So those details are being mentioned here in the disadvantages of the existing system part. And coming to the proposed system, so what are the things that we have discussed, that is we have developed using Python, HTML, CSS, and about the classes here which I have mentioned. So here you can see the classes names, the 7 classes: obesity type 1, obesity type 2, obesity type 3, overweight level 2, normal weight, and insufficient weight. So these are the 7 classes in the existing system. There are only 3 classes they have used. So here you can see that they have used only 3 classes, that is increase, maintenance and decrease. Here you can see we have large data set with contains of 7 classes of this: obesity type 1, type 2, type 3, overweight level 1, overweight level 2, normal weight, and insufficient weight. So we can accurately classify and we can predict the obesity using our proposed model. So those details have been mentioned in the proposed system part, which are the model details and the accuracy details, and the data set details have been mentioned here. So everything is been summarized in this proposed system part. And coming to the advantages of proposed system, So the main advantages that we are going to use two different machine learning machine learning algorithm, and they achieved 100% training accuracy and 98% test accuracy, and we are using different data set with the different attributes of it, so that it can be predicted efficiently, and we are going to use the WIP framework with the machine learning model. And finally we have summarized all the advantages of our proposed system in this part. And coming to the system architecture, so the input is given with the input obesity data set has been given, and pre-processing feature selection is made, and we are going to train up with the XGBoost classifier and stacking classifier. The predicted result will be on any of the class like obesity type 1, type 2, type 3, or overweight level 1, overweight level 2, normal weight, or insufficient weight. And finally we'll be showing the performance analysis and the graph part. So this is the minimum hardware requirement and software requirement. So this project can be executed in Windows 10 or 11. The coding language that we have used is Python 3.12.0. Brief framework is Flask. Frontend part contains HTML, CSS, and JavaScript. So this is the IEEE reference paper. So now let us see the execution of the project. So before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python and the libraries installed in it. So now inside the source code location, we'll be having this obesity prediction folder. Inside that we'll be having the app.py file, another file. So here in the address bar, let me type cmd and click enter. So the command prompt window opened with the exact location of it. Now type python space app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome and paste it and click enter. So now you can see the home screen or welcome screen of the project with the project title obesity risk prediction using machine learning. So just click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin, and then click the login button. So now it will be navigated to the upload part where you need to upload the data set. So just select this choose file option. So now go into the source code location. Inside that we'll be having this obesity prediction. Inside that we'll be having this upload.csv file. So just select this file and then click upload button. So now it will be navigated to the preview part where you can preview the data set that we have uploaded. So here you can see the data set, that what all the features that we have mentioned, everything is being loaded into the preview part of it. So now if you scroll down to the end of the page, you can see this click to train or test button. Just click it. Now after a few seconds you can just see this training finish message and click OK. So now it will be navigated to the important part of the project, that is the prediction part. So here before entering the features, here you can see finally you can see the option of having a drop down with the model part. So here you can see the model, both the model that we have used as XGBoost and the stacking classifier is been shown. So user can able to select whichever the model they can wanted, and they can enter and predict the result. So let me show you with the few cases of it. So first case, let me enter the gender as male, age as 27, height in meters as 1.8, weight as 87 kgs, family history of overweight, no, frequent consumption of high caloric food, no, consumption of vegetables, the value is 3, the number of meals per day, value is 3, consumption of food at certain time, sometimes, smoking habit, no, daily water intake, values 2, calorie consumption monitoring, that is no, physical activity 2, time using technology TUE is 0, and frequently, transportation mode is walking. So this is the value for the first case. I just entered these values. Let me select the first case as XGBoost and then click this predict button. So now it will be navigated to the result page where you can see the values that whatever the thing that we have entered is being shown, and finally you can see the predicted result is overweight level 1. So here we have given an option of downloading this PDF. So just click download PDF in the desktop. Let me save it as 1. So just you can export the values, whichever the values that we have entered, for just a future reference you can just use it. So now if you wanted to check for the other case, just let me go to the predict menu again. So now let me enter the values. Now for the second case, let me quickly say you the gender is female, age 21, height 1.62, weight 64, family history yes, frequent consumption of no, consumption of vegetables 2, a number of meals 3, consumption of food sometimes, smoking habit no, daily water intake 2, calorie consumption monitoring no, physical activity 0, time using technology 1, alcohol consumption no, transportation method public, and finally I'll select the model as tracking this time and then click the predict button. So now you can see the values that we have entered, and finally you can see the predicted result is normal weight. So now let me go to the predict menu again. I'll just give you other case quickly. So for this case I have given gender as male, age 22, height 1.78, weight 89.8, family history no, frequent consumption no, consumption of vegetables 2, number of meals 1, consumption of food sometimes, smoking habit no, daily water intake 2, calorie consumption no, physical activity 0, time using technology 0, consumption alcohol sometime, transportation public, and model I selected is XGBoost and click the predict button. So now you can see the predicted result is overweight level 2. So now let me go to the predict menu again to show with the other case of you. So for this case I have given gender as female, age 23, height 1.65, weight 90, family history yes, frequent consumption of high calorie food yes, consumption of vegetables 2, number of meals per day 3, consumption of food sometimes, smoking habit no, daily water intake 3, consumption calorie consumption no, physical activity 0, time using technology 1, alcohol no, transportation public, and model is XGBoost. Let me click the predict button. So in this case you can see the predicted class is obesity type 1. So now let me go to the predict menu again to show with the other case to you. So for this case I have entered gender female, age 25, height 1.63, weight 93, family history no, frequent consumption no, consumption of vegetable 3, number of meals 4, consumption of food always, smoking habit no, daily water intake 1, calorie consumption no, physical activity 2, time using technology 0, alcohol consumption no, transportation method public, model that is stack, and let me click the predict button to find the result of it. So this case is being classified as obesity type 2, and let me go to the predict menu again to show you the other case. So for this case I have given gender as female, age 26, height 1.584782, weight 105.0556, family history yes, frequent consumption yes, consumption of vegetable 3, number of meals 3, consumption of food sometimes, smoking habit no, daily water intake 1.197667, calorie consumption no, physical activity 0, time using technology 0.534769, alcohol consumption sometime, public transportation, and model use XGBoost. Let me check the predicted result for this by clicking the predict button. So for this case it is predicted as obesity type 3, and let me go to the predict menu again to show you a final case with the gender female, age 22, height 1.67, weight 50, family history yes, frequent consumption no, consumption of vegetable 3, number of meals 3, consumption of food sometime no, smoking habit no, daily water intake 3, calorie consumption monitoring yes, physical activity 2, time using technology 1, consumption of alcohol sometime, transportation public, and model let me select stacking, and let me check the predicted result for this, and now you can see the predicted case is insufficient weight. So till now I have shown you 7 cases with normal weight, overweight level 1, overweight level 2, obesity type 1, obesity type 2, obesity type 3, and insufficient weight. So in this case, in this way you can check with other cases that is available in the test or train values. So now let me move to the other part, that is the performance analysis. So in the performance analysis, you can see the performance analysis parameter of confusion matrix and the precision recall and F score for both the models. So first let me go with the XGBoost model. So for the XGBoost model, you can see the confusion matrix of the true and predicted label of it with the 7 classes. And coming to the classification report, so here you can see the precision recall and F score value for the each class, and you can see the final accuracy value and average accuracy and weighted accuracy, which is 98%. And you can see the cross validation scores of it and mean CV accuracy. And then for the next model, that is the stacking model, you can see the confusion matrix with the true and predicted label of it, and classification report with the precision recall and F1 score values with the classes of insufficient, normal weight, obesity type 1, type 2, type 3, obesity, overweight level 1, level 2, and accuracy value with macro average and the weighted average. And here you can see the cross validation scores of it with the mean CV accuracy. And finally the chart part, and this is a static visualization chart which contains the model performance chart. So here you can see the model accuracy comparison of both the algorithms, so which contains 98%, and next comes the distribution of the age. So here you can see the distribution of age chart and weight distribution of obesity level and gender distribution chart with the male and female count, and average weight by transportation mode. You can see there are public transportation, walking, automobile, motorbike, bike kinds of classes here. So you can see those graph here, and here you can see the height versus weight by obesity level graph and age distribution by obesity level, you can see. And next comes the weight distribution by the obesity level. So these are all the static visualization charts that is available in the chart part. And let me log out. And before concluding, let me show you the frequently asked questions which may be useful in the Viva voice. So the first question is, what motivated you to work on this obesity risk prediction? So this obesity risk prediction is a public health issue which affects millions of people all over the world. So this can help to many people to get prevented from the obesity, so that they cannot have diabetic or health issues like heart attack kinds of things. So this is the motivation that you can answer. And what data set did you use for the project? So this is a standard obesity data set which is referred from Kaggle, so which contains 2111 instances, that is data set record with 17 attributes. So those results you can explain to the guide or the external. So which machine learning model did you implement in the system and why? So you can say about the machine learning model XGBoost classifier and the stacking classifier. So because it can handle large data set with high accuracy. So those that accuracy model details can be, you can answer them. So how did you pre-process the data before training the model? So the pre-processing includes the steps like data cleaning, encoding categorical variables, feature scaling, and splitting the data set into the training and the test part. So those details you can explain it. And what evaluation metrics did you use to assess the model performance? So whatever I have shown you finally, that is the precision recall F1 score and also confusion matrix. Those details can be used for the assess the performance model. So next question is, can you explain the significance of the features used in the data set? So I have already said about the features, that is FAVC, FCVC, CH2O. So you can explain those feature details. what challenges did you encounter during the project and how did you overcome them? So the primary challenge is dealing with the missing or inconsistent data. So we have used data cleaning techniques and applying the imputation method to fill the missing values wherever necessary, and then fine tuning the model to achieve the optimal performance required with the hyperparameters. So these can be addressed for this question. And how can the results of your prediction can be utilized in real world application? So how for the real world application, this can be used by the healthcare providers, nutritionists and fitness professionals, so that they can access the individual obesity level. Accordingly they can diagnose it. So what are the future directions? So future directions, like you can use different data set features, and also you can develop mobile app for that users can easily monitor, like in app format also, so in that way you can answer. So these are the frequently asked questions and answer for it. So this is all about the project obesity risk prediction using machine learning, and thank you for watching.